In this video, we're going to talk about Wein's law, also known as Wein's displacement law. Blackbody radiation curves from different black bodies of different surface temperatures will peak at different wavelengths, and that peak wavelength value is inversely proportional to that object's surface temperature. Let's break down this definition. First of all, we're looking for blackbody radiation curves from different black bodies of different surface temperatures. So let's say we're looking at 4 different stars. One star has a surface temperature of 3,000 Kelvin. The second star has a surface temperature of 4,000 Kelvin. The third star has a surface temperature of 5,000 Kelvin. And the fourth star has a surface temperature of 6,000 Kelvin. So we have 4 different black bodies, 4 different stars, of 4 different surface temperatures, and therefore we will have 4 different blackbody radiation curves, and each of them is outlined with a black line. Notice that on the horizontal axis we have wavelength with increasing wavelength to the right, and we have intensity or amount of that light at that wavelength increasing in the vertical direction. Notice the peak we're looking at. We have a curve. Each of the blackbody curves will peak at a different wavelength. So let's go take a look at that. So here's the peak of the blackbody from the 6,000 Kelvin object. Here's the peak of the blackbody from the 5,000 Kelvin object. Here's the peak of the blackbody from the 4,000 Kelvin object. And here's the peak of the blackbody from the 3,000 Kelvin object. Notice as the wavelength goes up, so as we have an increase in wavelength, the surface temperature of the object goes down. And this relationship is what we see in this part. The wavelength value is inversely proportional to that object's surface temperature. This general equation that we have here is the general form of Wein's law, which is a constant, a value that is known, is equal to the peak wavelength multiplied by that object's surface temperature. And this is what we mean by Wein's law.